Hey everybody, today we're going to be talking about some exponents and also their properties. Exponents basically mean powers. So we're going to see a few rules that apply to exponents and exponential expressions. Then we're going to see how to use them, how to apply them to simplify some expressions. So let's start first by defining exponents or powers. For example, we've seen some expression like this. So when you see this is basically 2 to the third power. 3 is the exponent, or we also call it power. And what do we call 2? If this is the power, what do we call the 2 here? It has a specific name also. Does anybody know what do we call it?
Can you repeat again?
3 is a power or the exponent.
Coefficient.
Not coefficient. It's under the power. So
It's
as a name. So we call it the base.
oh yeah.
Okay, the base of the power 3. So what this means is this basically is 2 to the third. And what is that equal to, or how do we find the value of this expression?
We multiply 2 by 2 by 2 3 times.
That's right. So you're going to times, you take the base and you multiply it by itself 3 times. If you have 5 here, you multiply 5 times and so on. So 2 is repeated. 1, 2, 3, 3 times. With a multiplication, not addition, but a multiplication in between. And then you simply multiply 2 times 2, that's 4, 4 times 2, that's 8. That's it. So this is the value. This is the value of this expression. And we call this the expanded form. We take this and you break it down into multiplication. We call that the expanded form. So that's pretty much what we're going to be discussing today. Different form of these, different signs, different types of real numbers. So we say 2 to the third power is 8, the value. So this is the exponential form. This is the expanded form, and this is of course the value. Both of these can be any types of numbers. They could be decimals, they could be negatives, positives, fractions, all sorts of real numbers that we talked about before apply here. Let me give you another example. How do you say, or how do you read this expression?
3 for the
Three a part of 4.
That's right, 3 to the 4th power, or 3 to the 4th. Okay, so to find the value of this, it's not 3 times 4. Okay, a lot of people make that mistake. It's not 3 times 4. Again, what do we do to find the value? The value of this exponent.
4 times multiply 3.
That's right. So 3 is going to be multiplied 4 times by itself. 1, 2, 3, 4, because the power is 4. Again, if the power is a different number, this will be different. If you have 7 here, you will multiply 3 by itself 7 times. So once you expand it, then you try to simplify. Don't try to do the whole thing at once. Maybe do 2 at a time. 3 times 3, that's 9. Then do the other 2 together, that's 9. But come back again and do 2 at a time. To multiply these 2, we get 81. So 3 to the 4th power. Okay, we expand and we multiply. Sometimes the power can be too big. For example, if you have 20 here or 100, it's going to be a very big number. So it'd be very long to expand it like this and then to multiply it manually. But we can always do this with a calculator. The numbers are big. There is a button in each calculator. It's like this. And each calculator has a button. It has X, base, and y as the power. You can use that to evaluate large power expressions when it's too big to basically multiply manually or to expand. This also applies to fractions the exact same way. So if you have, for example, 2/3, that's a fraction, the base, the power is 4. Same thing. So this is the base here, 2/3, and the power is 4. So you take 2/3 and you times it by itself 4 times. 2/3, 2/3 times 2/3, and so on 4 times. Or we can also split it. Instead of having one fraction to the 4th power, we can split it. We can say 2 to the 4th and 3 to the 4th. Because the 4 belongs to the entire fraction, not just to the 2. So we can split the fraction into 2 expressions, 2 to the 4th over 3 to the 4th. Then you evaluate each one. What is 2 to the 4th? If you add basically another 2 here, multiply this by 2, it would be
16.
very good, 16. And this one we just did here, 3 to the 4th is 81. So that applies to fractions and decimals also, all sorts of numbers basically, any real number, same thing applies. Be careful here with the fraction. You have to have parentheses in order for the 4 to be for the entire fraction. If you have something like this, for example, so this doesn't have parentheses, which means 2, the power 2 belongs to the 5 only, not to the 4. Only belongs to the 5. So this would be 5 to the 2nd, which is 25. That's right, over 4.
4, 2.
That's right. So the 4 does not get the power. The 4, because we don't have parentheses like that. So power 2 only belongs to this. But here, the 4 belongs to the entire fraction because of the parentheses. Or it could be just here. So all depends. Okay, so that's basically a little introduction to powers. Now let's see what happens if you have negative numbers. You may have a negative here in the expression or a negative here in the power. So let's start with negative bases. So there's a difference between this expression, the difference between this and this expression. They're not the same. So let's see how to evaluate both. What's the difference between the two? For example, what do you think this one is? What is this one equal to? What is that one equal to here? Negative here, 3 and 2. Here we have negative 3 in parentheses to the 2nd power.
Is it gonna because it's exponent 2, it's like it's gonna be positive. It's gonna be like negative 3 multiplied by negative 3.
Okay, so that would work here, but not here. Because for this one,
is negative 3 multiplied by 3, positive 3. So it's negative 9.
It would be, that's right, it would be negative 9 because 2 belongs to the 3. The minus is not part of the base. The minus is independent. So the minus is there and we expand this. So the power is directly to the number 3. So this is 3. That's right, it's to the number. So this minus will stay here. So this will become 9. But this one, minus is part of the base. So the base is everything inside the parentheses and the 2. So if we expand this, we're going to multiply negative 3 by negative 3.
By negative 3, it's positive 9.
Exactly, that would be positive 9. You see how it's different from this one. This one is negative. So if you don't have parentheses, the minus is not part of the base. Just write it down, bring it down, then expand this. But if you have parentheses, whatever is inside the parentheses, the whole thing is base to the power. If you don't have parentheses, only what's directly under the power is the base. For example, here 5 is the base, not the 4. So these are different. So there is that's the difference between these two. So let me give you another example. So if you have, for example, -5 to the second and -5 to the second, they're not exactly the same. What is this one equal to? What's that equal to?
That one's gonna be like positive 25.
Mm-hmm. That's right. So
And
-5
this one's gonna
times
be like
-5.
negative 25.
That's right. And this one would be negative. This negative will always be here because we don't have parentheses. Then 5 to the second is 25. So one is positive, the other one is negative. So the parentheses is what determines what the base is. If you don't have parentheses, again, what's directly under the power is the base, not the numbers or the signs before or after that. So that's basically what happens when you have a minus in the expression. It could be part of the base if you have it in parentheses under the power, or it might not be part of the base if you don't have parentheses. So that's what happens basically when you have negative powers. Now let's see what happens if you have negative in the, negative bases. These are negative bases. Let's see what happens if you have a negative here in the power. So negative. So like I said, the base and the power, they are real numbers. They could be all sorts of numbers or sorts of signs. For example, you may have, let's say, 4 to the second power, which is not the same as 4 to the power -2. So this, we know, is going to be 16. But this one,
It's 1/4 in the second.
that's right. So if you have positive power, it's just 4 times 4 is 16. If you have a negative power, it's not going to be -16. It's not going to be -16. What we do is we actually flip it. First, make it a fraction. Just make this one a fraction. Then we kind of flip this or move this down. Move this down, and the negative power turns positive. Turns positive 2. So 1 over this. Then now we can say 1 over 4 over to the second is
16.
16. So if you have a negative,
Right?
if you have a negative power, basically we flip it to make it positive, then we simplify it. So again, when you see a 4 to the -2, it's not -16. It's actually 1 over 16. So if this was a positive, you would say 16, but if you have a negative, just flip it, say 1 over 16. So you don't have to do these steps, you can just say it right away. So 4 to the second is 16, but 4 to the -2, instead of saying 16, again, we say 1 over 16. Here's another example. What is 6 to the power -2 in one step? 6 to the power -2 in one
It's
step.
like 1 over 36.
1 over 36. That's right. Instead of saying 36, if it was positive, it would be 36. But because of the negative, just flip it. Say 1 over whatever whatever the value is. So 1 over 16. I'm going to talk more about the negative exponents. So again, it's because we made it positive. We moved it down. Same thing. So also if you have, let's say, a fraction, right? The entire fraction, for example, has a negative power. We can also make this one positive. We can make this one positive by flipping the entire fraction. So we're going to take this fraction, flip it, and this will turn positive. So this will be 4 over 3. Okay, we flip this, and the power becomes positive. So once the power becomes positive, we can, again, evaluate it or simplify it this way. So 4 over 3 to the second, it means 4 over 3 times 4 over 3, which is 4 over 3 times 4 over 3 is
16 over 9.
That's right, 16 over 9. So, so whenever we have a negative power, we make it positive. And when it's positive, we evaluate just like we did here. Okay, so let me give you another example. What if you have something like this? Let's say 7 to the power -2 over maybe 3. So what is the base? What's the base of this power -2? The base is?
It's gonna be like
The base, what is
we're
the
gonna
base?
flip it. We're gonna flip it, right? It's gonna be like 3
Okay,
over
so let's
7
first
plus 2.
define the base. What is the power here is -2. What is the base of this power?
7.
7,
40,
right?
yeah,
Just 7, not the 3, because we don't have parentheses.
7,
So
yeah.
the base of this power is 7. So we're not going to flip the entire fraction. Unlike here we flip the whole thing because -2 belongs to the entire fraction. Here, the -2 only belongs to the 7. So we're not going to flip. Instead, we're only going to move this one down. We're not going to move the 3. Just move this one down to make it positive. So this will be 7 to the second. And the 3 stays here. So nothing left here but 1. If you move this down, the invisible 1. So power becomes positive, then we can simplify it. So 7 to the second is 49, which you times by 3, and it will be 147. I mean 1 over 147. Okay, so it would be 1 over 147. That's the answer. So if you have a negative power, you move only what's negative. Unless the negative is over the entire fraction, then you flip the entire fraction. If it's just one thing that has a negative power, you only move that specific number to the other side of the fraction to make it positive. It could be here, or it could be at the bottom of the fraction. For example, you may have 3 to the power -2, and maybe let's say 2 here. So what do we do here? Or what needs to be moved?
Replace on
Which one needs to be
upside.
moved?
3 in a negative power. I don't know.
That's right. So we're going to move this up to make it positive. We don't move this. It stays here because it doesn't have a negative power. The power here is invisible. It's 1. So no need to move it. So this stays here times 3. We move this up, it becomes 3 to the power 2. So whenever you have a negative power, you just move it to the other side of the fraction. Move it up or down, depends, it becomes positive. So now it's positive. So we're going to do 2 times 3 to the second, which is 9. And this is 18. Okay, so that's how you deal with negative powers. Simply move them to the other side to make them positive. Or if the negative again is over the entire fraction with parentheses, you flip the fraction, the power becomes positive. So that's important when it comes to powers. We can easily turn any negative powers into positive powers, and they become more familiar and easier to manage when they're positive. Okay, you guys got this part? Any questions? Everybody? Any questions?
No.
Everybody else, you okay? I don't hear from everybody.
Okay.
So you said when we get a negative, you flip it? Like the second problem, like 4 to -2 power.
Okay.
So instead of it being 4 over 1, it's going to be flipped to 1 over 4, right?
That's right. So we basically move that down. the negative power moves down, becomes positive. Then we evaluate. 4 to the second is 16. We have 1 here, so 1. So instead of 16, we say 1 over 16. Same thing here with the 6 to the power negative 2. So instead of saying 36, we say 1 over 36. So if you have a negative, you say 1 over, you flip it.
How many variations are there?
Basically, just these. It could be 1 by itself, or it could be a whole fraction to the negative power. It could be 1 by itself.
So what about
like
the
here.
one to the right? Like the 7 over 3 to the negative second.
Yeah, so this is
That's the same
just
thing.
one number by itself, one number to the negative power. You move it down, or if it's down, you move it up. If it's over the entire fraction, if the negative is over the entire fraction, we flip it. We flip the entire fraction. Or sometimes both can be negative. For example, 5 to the power negative 2 over 3 to the power negative 2. So in this case, both are negative powers. So we're going to move both. Basically, we're going to flip again the whole thing. So this moves down, this moves up. So this becomes 3 to the power 2 over 5 to the power 2, which is 9 over 25. Okay, so move what's negative. Only what's negative. If both are negative, of course, we move both and we flip. So these are pretty much all the cases you might see. And again, the bases and the powers could be any sort of numbers, fractions, decimals, negatives, positives, and so on. Okay, so that's basically a little introduction here to powers. And one more thing. When you have any number to the power 0, for example, 7 to the power 0, what is that equal to?
0.
Not 0,
7.
not
1.
7, 1. That's right. Any number to the power 0 is 1. Any real number x to the power 0 is always 1. So remember that. That's a rule of the exponent. And basically, if you have parentheses, for example, and whatever the base might be inside here, whatever it is, the numbers, the variables, so the 0 is the power for what's inside the parentheses. So no matter what this is, the value will always be 1 if you have parentheses. But if you don't have parentheses, for example, just x and y to the power 0, so the 0 power belongs to the y only. The 0 is for the y only, not for the x, as we saw earlier. We don't have parentheses, so that's the power, this is the base. So what is this one equal to?
X.
Can be x.
Exactly, just x. So it's going to be x times
Because y
1.
equals 0.
That's right. Y to the power 0 is 1. So that's x. So again, be careful if you have parentheses or not. If you have parentheses, everything inside the parentheses is the base. So anything, whatever these numbers are or these letters, to the power 0 will be 1. But if you don't have parentheses, only what's directly under the power turns into 1. So this turns into 1, but this stays. The power for this one is invisible 1, so it stays here, x or x1. So that's another rule. So remember that if you raise anything to the power 0, it will be 0. That's pretty much a lot of introduction here. Now let's get to the actual properties. We have about 6 or 7 of them. We've seen a couple here. I'm going to write them down later. We've seen a couple here with the minuses and things like that. Now let's see the other properties of the exponents. Number 2, properties. Of exponents. So the first property says, basically when you have, let's say, some base, some real number, like we did here, fraction or decimal, positive, negative, some base, let's say to a power of 2, for example, and you want to multiply this by another base, another basically same base, but maybe a different power, for example, 3. X to the power 2, multiply x to the power 3. What is that equal to? What is this equal to? If anybody has an idea, what is it?
X in power 2 plus 3.
That's right. So
Maybe
you
we
just
can
add,
the power.
you just add the powers. That's right. 2 plus 3, x is 5. So the same base, we have a multiplication, and the powers add up. Okay, so the powers add up. It is a multiplication here. It is a multiplication, but the powers, we add them. So that's important. Keep that in mind. But the base has to be the same. The base must be the same. Let me give you another example. Let's say you have -4 times maybe 9. So again, multiplication, same base. What is that equal to? If we combine the powers, what do you get?
X in power
32.
5.
That's right, x to the power 5. So we combine them. So we combine this with this.
Oh,
Basically,
yeah.
add them or subtract based on the sign. So -4, okay, plus 9. So we just combine the two. So x is, or x to the power 5. Okay, so again, just combine powers of any signs. Basically, add or subtract based on the signs. Both powers could be negative, for example, here. Okay, x to the power -4, 2, x to the power -1. What is this equal to?
-3.
X to the power -3, that's right. We combine the two. So -2 minus 1. And x to the power -3. So
1 over X.
that's right. So now, just like we did here earlier, see how we made this positive? When we flip, we turn the powers positive. That's what we're going to do here. So basically, we're going to turn this into a fraction and just move that fraction down like this. Move the x to the power -3 down to make it positive. So this turns into 1 over x to the power 3. So make sure you make your final answers should have positive powers only. If you end up with a negative power, simply move it to the other side, just like we did here. If it's down, move it up. If it's up, you move it down to make it positive. So your answers should only have positive powers. That's important. Okay, so that's basically the first rule of exponents. Let me write the rules for you here separately. So there's again about 6 or 7 of them. We're going to list all of them, summarize all of them. So rules of exponents, also called the rules of powers. Okay, powers and exponents mean the same thing. The first one we just saw, it says again, if you have any base x to the power a, and you want to multiply that by the same base but to a different power, what is that equal to again in general?
X in power a plus b.
That's right. Just add whatever powers you have, combine them. They could have different signs, like I said, but combine them based on that. That's the first rule. Okay, pretty simple. So when you multiply, again, remember we add the powers. Now let's see what happens if you have a division. Instead of a multiplication, we have a division. In other words, a fraction. Let's say x over 5, x over 2, right? And we have a division here. If you have the same base, basically you subtract. You're going to subtract the 2 powers. So instead of adding, when you have a multiplication, here with the division or a fraction, you subtract the 2 powers this way. 5 take away 2, which is x to the 3rd. That's it. We just simplified this into that. And again, these could be different signs, could be different. So whatever, just subtract them, whatever the value is. Here's another one. Let's say you have 3 or 4 over 9 here. So what is this equal to? What do we do here?
Power x in power 4 minus 9.
Okay, and that would be?
Minus 5.
That's right. So this, take away this. So 4, take away 9, which is -9. -5. Always subtract in this order, not the other way around. The top minus the bottom. And what else we do? We need to do to this.
You can now reverse it, right?
That's right. So we need to make it positive, just like here. It becomes 1 over.
1 over x. Yeah.
Exactly. So always, if you end up with a negative power here, turn it positive simply by moving it down.
So, Professor,
Mhm.
quick question, right? Whenever we have a negative exponent, we always have to do this.
Yes, make it positive. So
Make it positive.
yes, the expression should, or the answer should always have positive powers.
Okay.
Okay, so this is the second. So our second rule. So x to the power a. In general, x to any power a over same base to some other power b. What is this equal to? X to the
A
power.
minus B.
Exactly. A minus b. Whatever a and b might be here, could be positive, negative, whatever it is, again, subtract it. Okay, that's the second rule. The third rule is this. It says if you have one base and you have power, then another power on top of the first power. Only one base, not two bases like here. Just one base to a power and then another power over everything. How do you simplify these two powers? What do we do?
Maybe multiply.
That's right, we times it. So it's going to be x 2 times 3, which is x6. Very simple, just times them and that's it. Don't confuse this with this one. Here we have two bases. We multiply, we add the powers. We add. For this one, there's only one base, 2 powers. And we times the 2. Not 2 to the third, not 8. Okay, not 2 to the third, 2 times 2 times 2. It just this, multiply this. That's it. And you get your value. If you have even another power, you times it as well. If you have 2, 3, and another power 5, just multiply all of them. 2 times 3 times 5 into 1 power. And these could be any signs, okay? They could be negative, could be positive, doesn't matter. Just multiply whatever you have. If you end up with a negative power, make it positive, or you end up with a positive power like this. Here's another example. Let's see you have negative x to the power -4, and maybe another power outside 5. What is this equal to?
Multiply my -4 and 5. It would be -20. Then flip.
Okay. Then make it
1 over x and power to the power 20.
That's right. So that's a negative power, and you'll flip it becomes x to the power 20. And it is also possible to have both powers. It might be both negative, for example, this. So x to the power -2, and then another power -1. What is that equal to?
Negative, again, positive 2, x positive 2.
That's right. We
Because you
multiply
can-
them. That's right. We multiply them. Negative times negative will be positive. And that's it. You don't have to flip it because obviously it's a positive power. Okay, just times whatever powers you have. And that's pretty simple. So the third rule is that. So let's write the rule again here in general. So if you have x to a power a, the whole thing to a power b, what is it equal to? Everybody? What is that equal to?
A multiply with
AB.
AB, that's right. A, B, which means A times B. So the first one we add, second one subtract, third one we multiply. So they're distinct, okay? Make sure you know exactly what you're doing. These rules here, the exponents, are very, very important in this class. So this class is based on this. This is the backbone of this college algebra class. We're going to be using this in every class. From now to the end of the semester, we're going to be involved in variables and powers So we need to understand exactly how to deal with them. So we're going to use them for almost every other topic: equations, functions, polynomials, and a bunch of other things. So understanding these will make the class very, very easy for you. So 90% of the time we'll be using this. So these rules here, 3, I'm going to write the other 2 or 3 here. Those are pretty much the most important thing we're going to be needing for the class. So understanding them again, like I said, will make your life a lot easier, and you will make it very easy to understand the future topics like factoring, and polynomials, and solving many other things. So we're going to be using this whether directly or indirectly to do other problems. 1, 2, 3. The 4th rule, it stems from here. We've already seen these, seen a couple of rules here with the negatives. So basically, like we said before, if you have any power or any base to a power that's negative, what is this equal to again?
1 over x
Okay.
to the power a.
That's right, to the power a or positive a. So we've seen this before. This number 4. Number 5 we've seen also. We've seen it earlier. So x over y, for example, in a fraction to a power, to some power that's negative. What is that equal to? Or in other words, how do we make that power positive?
Apply to the both x and y.
Okay. And everybody, what is that
we
equal
have-
to? How do we make this
We have
positive?
we have to flip it. So it would
Okay.
be y over x, and power would be positive.
That's right. So we're going to
Open
flip this.
The both side. That's it.
Okay. Okay, so that's right. We're going to flip the fraction, the entire fraction, to make the power positive. Basically, this is what we did here. So we flipped the whole thing to
Mhm.
make it positive. It's exactly what happens here. Again, x, y, and a are real numbers. It could be any numbers, no matter what numbers you have there. So you flip it. Flip your fraction over x to the power positive a. And of course, there's another one, number 6. So far we've seen like what happens if you have the same base and different powers, right? Now we're going to see the opposite. We're going to see different bases and same powers, same power. For example, x and y, and the power is the same. So basically, it's the opposite of this. So x to the power a times y to the power a. So we can combine these together. Since they have the same power, we can put them together in parentheses and raise them to the same power a. Because they share the same power, we can combine them. Or sometimes if you have this, you can break it down into 2 of them by basically simplifying this. So we can go back and forth between the two as needed. For example, if you have, let's say, another example, A, B, and C, and let's say all these 3 bases happen to have the same power. So D belongs to all of them because of the parentheses. So we can split them if we need to. As we're going to see in the future, sometimes we need to break powers down or put them together. So this we can write as A to the power D by itself, then B to the power D, C to the power D. So that's another rule of exponents, which allows us to put bases together if they have the same power. Okay, they must have the same power. So don't confuse this with this one. Here we have the same base. We add the different powers, but here it's the opposite. And the last one basically is this one here, this rule that we saw here. So as we said earlier, any real number, any number of these numbers we saw raised to the power 0 is equal to what?
1.
Always equal to 1. That's right. What about these 2? This and this with parentheses. So a to the power, or a times x to the power 0, here ax together to the power 0. What is this equal to?
What? For the
A,
first one,
first A.
I'm sorry, say
multiply
again.
by 1.
A,
A, that's right. So it's
Yes.
a times 1. That's right. A times 1, which is basically a. No parentheses, so this stays. 0 does not belong to this, only belongs to this. But here the 0 belongs to the whole thing. So anything to the power 0
One.
is 1.
1.
Exactly. So anything to the power 0, just like here, is 1. So be careful with the parentheses. So if you have parentheses, what's inside of them is the base. What's inside the parentheses is the base. If you don't have parentheses, only again, what's directly under the power is the base, not the other stuff next to it. So for example, this turns into 1, and you times it by a, you get a, and here the whole thing is raised to the power 0 set. That's equal to 1. So these are basically the rules we're going to be using over and over and over again for almost every topic. So very, very important to not only remember, but to understand these rules. Understand them first. Then, of course, remember exactly what to do to add, subtract, multiply, and so on when needed. So that's your guide for this class. All the stuff that we're going to see will involve these powers. 6 of them or 7, no big deal, but they are very useful, and we use them to manipulate expressions, simplify, and make complex expressions simple, solve second degree, third degree equations, factoring, as I mentioned before, and many other topics as we're going to see in the future. So for the next, I don't know, next 5 classes or so, always go over this first. Just take 2 minutes to review this. Every time you want to do the homework, before you do the homework for the next 5 classes or so, or maybe every class before you do any homework, just go over these. Take 2 minutes. Just refresh your memory on these rules here, because they are very, very useful. And again, the entire class is based on these rules. The entire class, we're going to be applying these for 2 different topics. Okay, everybody, any questions about any of these rules we've seen, or any of these examples we've done?
No.
Okay, everybody else, are you guys all right? Make sure you understand these rules. This is everything about the class here. Very important, like I said. Can't stress enough how important these rules are. Okay, so let me know again if you have any questions from here. If not, I'll give you a few of these, some of these, so you can practice. Okay, I'm gonna give you a few practice problems based on these. So all right, let's see. Evaluate or simplify. A lot of time the question will say evaluate or simplify when it comes to expressions. For example, 2 to the 5th, evaluate or simplify, minus 8 to the 2nd, minus 8 to the 2nd. And maybe
We have to do it now.
that's right. Yeah, everybody take a few minutes, work on this practice. Again, as I always say, this is the time where you test yourself. Make sure you got it. You got it now. You should be able to do this fairly easily. Okay, so if you do, then you're fine. If you have difficulties, then that means you need to step up your game, review, or do something. So This is the best time to learn it. Don't wait to, till later. You may not understand it by yourself if you try to read the book or something, but give it a try now, and it should be pretty simple. If not, we're gonna go over them in a few minutes. All right, so evaluate these. What else? And 3 to the power -2 over 5. Also some variables. X to the power 3. And okay, and one more. Okay, so most of these will take you literally seconds. Okay, most of them will take you maybe 3-5 seconds to do, like almost immediately. And maybe 1 or 2 of them take you a little more time, maybe a minute or so. All right, so give this a try. The rules are here, the examples. Give you about 10 minutes or so, 10 or 12 minutes. So take your time again, everybody. Look at the rules, look at the steps, and test yourself with this set. Okay, I'll be back in a few minutes. Feel free if you want to take a short break, a few minutes, and come back to the review. You can do that. I'll be back in a few minutes. Everybody, are you done?
Good.
Yes, teacher.
Yes.
Yeah.
All right. Everybody else? Okay,
Mhm.
you finished?
Mm-hmm. Yeah.
How was it?
Not
How is
bad.
it? Okay.
Do you want us to tell you the answers?
Yeah, we're gonna do that in a moment. So this shouldn't be that bad. It should be pretty simple. And again, this is very important. We're gonna do more on these. We're gonna spend the next class practicing more of these, more complex ones with more variables. But this is good enough for today. The basic rules. We'll see some more applications next time. All right, so let's see. Let's go over these together. First one, 2 to the 5th, everybody. What is that equal to?
32.
Yeah.
32.
32.
32, that's right. 2 times 2 times 2 and so on. Negative 8 to the second.
Negative 67.
Negative
64.
60.
That's right. The
Yeah.
minus stays here. Negative 8 to the
That's
second. we put it.
Positive 64.
That's right.
64.
This is positive. So it's negative 8 times negative 8, which turns positive. What do we do first here?
You flip it, whatever.
That's right. Flip.
Yeah, it's
Yeah.
gonna give you 25 over 4.
That's right. Flip it. The power becomes positive. And then 5 to the third and 2 to the third. 5 to the third.
Oh no, that's sorry. I thought it was
5 to
2.
the third. Okay, 5 to the third is 5 times 5 times 5, 125. And 2 to the third is
125 over 16.
everybody. 2 to the third would be
8.
8. That's right, 8. So we flip the whole thing to make it positive. What exactly do we do here first? What do we do first?
Which one? This one, it's
1.
you flip it so you can get a positive exponent.
Do we flip the whole thing or do we move
Yes,
something? What
You
exactly?
flip the top
3.
one. So it's
Only
gonna
move.
be like 1,
Yes.
it's gonna be 1 over 5 multiplies to exponent 2.
That's right. So only move this one. This
Yeah.
stays here.
Mm-hmm.
This stays here. Only move this one because it has a negative power. The power becomes positive. Then you simplify. This will be.
It's gonna be 1 over 45.
1 over 45.
That's right. It's going to be 5 times 9, which is 1 over 45. What about this? What is that equal to?
Exponent
X
x
plus 5.
4 x4
4.
x
X4.
exponent 4.
That's right. So the power for x here is 3. What is the power of this x
Plus
if you don't see one?
1.
1.
Exactly. So whenever you don't see a power, it is invisible 1. So now, as we saw with the first rule, we add the 2 to be x4. And this also multiplication.
1 wait.
So
It's
now,
gonna be like because you're gonna have a flip it. You're gonna do x equals 7 plus 3 is
Plus
gonna
3.
give like x is negative
that might
4.
be one way. What about a second way, like we did earlier? So what do we do with these 2 powers?
You're gonna plus
Yeah.
it. You're gonna
Plus.
add
Plus, right?
addition. Yes.
So you have negative 7 and 3 would be
Negative 7
Next
plus
4.
3
Next 4.
is
Negative
gonna be
4.
negative 4.
negative 4.
So you're gonna flip it.
Now we're going to flip it. That's right.
1 over
You're
X.
gonna 1 over
X.
That's right. So whenever you have a multiplication, just combine the 2 powers. Combine them first. If it ends up negative, then you flip it. No need to flip in the beginning here. No need to flip this. First, just combine them. Now we have a fraction here. What do we do?
it's gonna you're gonna subtract
Okay, 5 minus
exponents.
8.
Plus
5
negative 3.
X.
5 minus 8.
That's right.
8 plus.
Negative 3. So 5 minus 8, negative 3. And this will be
We're gonna flip it. It's gonna give like 1 x
x to the power 3.
5.
Okay, so we flip it. Finally here, x, we have one base, two powers. What do we do with
Multiply.
2? Multiply. So x and the power. 4 times negative 2.
8. Negative
That's
8.
right.
I'm gonna flip it to give.
Okay, and again, flip it if you end up with a negative power. Okay, so that's pretty much it. I give you a lot of negatives here because that's what can be confusing. The other ones, the typical ones we did here. So it's important to understand what to do with the negatives and so on. Okay, so these are your main rules again, and some applications. So again, next time we're going to do more complex expressions. These are just basics. Here, for example, instead of just x times x, we're going to have two variables, maybe x and y times x and y, maybe some numbers. Same here. Instead of just x and x, we're going to have x, y, z over x, y, z, and so on. Any questions, everybody, about this practice or any of these rules?
Nah.
Okay, everybody else? Any questions, any issues?
No, sir.
No, we're all good.
Okay, so again, I keep repeating, this is very, very important for the class. Your rules here, review these every time you want to do the homework. That's going to make your math in this class a lot easier. Trust me, this is very important. They're very simple, but also very useful. And we basically will see them every time. This class is all about x's and y's and powers. So make sure you understand these rules and distinguish between them. They're not exactly the same. Sometimes we add, subtract, so know the difference, and so you can use them easily.